Right, here's a sort of a tougher question, and it sort of begs really understanding what Kas and Kbs and pH and hydroxide, hydronium, and weak acid, weak base. You need to understand all of that stuff. So the question says, what is the pH of a 0.1 molar solution of sodium hydrogen sulfide? So sodium hydrogen sulfide will look like that. And hydrogen sulfide, if you're looking for it on the acid-base chart, you can find it right there. So it's acting as a base. So if I have that in water, so it's a solution, so I assume there's water, I can take, so these things would dissociate, right, in water. So I'd have sodium ions and bisulfide ions. So if this acts as a base, I would react it with water, according to our Bronsted-Lowry kind of thing. And it would be at equilibrium with, okay, if this gives, or this takes on a hydrogen, so it would become H2S, and it would take one of the hydrogens from water to go there, so that it would become hydrosulfuric acid and hydroxide ions. So there's the main reaction that I'm looking for. I know the concentration of the sodium hydrogen sulfide. If I put that in water again, if I dissociate it, let me just do that. So NaHS, if I put it in water, it'll form sodium ions and hydrogen sulfide ions. Okay, so the hydrogen sulfide ions, those are the things that I'm reacting. And since they're fairly close to the bottom of the base side, they probably act as a base. You probably could give up that hydrogen there, but I don't even see HS on this side, so it's probably not a very strong acid. Okay, so this would be a weak base. The strongest base, of course, is hydroxide ion. This would be a weaker base. Whoops, I'm covering up my number that I'll need later. This is the Ka value if the reaction is going this way. So if I'm taking the hydrosulfuric acid and taking off a hydrogen and becoming this, that's the Ka, or the equilibrium value for that reaction. Now initially they tell me that the concentration of the hydrogen sulfide, that's this stuff, is 0.1 molar. So if I look for that, that's this one right here, 0.1 molar. That's the concentration of that. Water is a liquid, won't put a concentration there. But what I'm really looking for, in order to find a pH, I need to have what the hydronium ion concentration is. And I don't see that anywhere here, but if I figure out what the hydroxide ion concentration is, I would be able to find that using that the water constant, 1 times 10 to the minus 14th. Okay, so I know that this is at equilibrium, and I know if the reaction is opposite, if it's going this way, this is the Ka value right there. But what I'd like to know is what is the K value of it going this way. And so if I'm going left, if I'm using this as an acid, that would be a Ka value. But if I'm going right like I wanted to, then this would be known as a Kb value. So I know that Ka times Kb is equal to the equilibrium water constant, which is 1.00 times 10 to the minus 14th. So I can take this number over here, and from that figure out what my Kb value is. Let's do that. So the Kb value is going to be 1.00 times 10 to the minus 14th, divided by, so I'm looking for this, so I'll divide both sides by Ka. I guess maybe I shouldn't have put this in the middle there. There's your equation, and I'm dividing both sides by Ka, and the Ka value is 8.9 times 10 to the minus 8. Okay, so if I divide those, I get 1.124 times 10 to the minus, 1, 2, 3, 5, 6, 7, negative 7. Okay, so that's my Kb value. And really why I wanted that was so that I could write an equilibrium equation for that reaction there. So an equilibrium equation for that would be the concentration of these, let me do it in a different color, concentration of this and this divided by the concentration of this. So it'll be the concentration of H2S times by the concentration of hydroxide ions, which, since they're 1 to 1, both those values will be the same, divided by the concentration of HS minus. Now, I know for this reaction that the Kb value, or the equilibrium constant, is this number. So I'll plug that in. So 1.124 times 10 to the minus 7th is equal to H2S. We're just calling that, we'll call that X because we don't know it. And the hydroxide will also be X, divided by the concentration of HS, which is 0.1. Now, they did say in the question, I erased it, but they say assume the acid concentration doesn't change. And so if the acid concentration doesn't change, like this number here, if you're at an equilibrium, you'll use up some of this to produce the stuff on the other side. But because this is such a weak base, the amount that 0.1 changes is negligible. So we'll just assume that it's 0.1. And that's one of the reasons why they said that assumption in the question. Okay, so now I've got x squared is equal to 1.124 times 10 to the minus 7th. And then I'll have to take this and multiply it by 0.1. So multiply both sides by that. Let me do that on the calculator. So I'm timesing that by 0.1. Okay, so, and that's what x squared is. And then let's take the square root of it all at the same time. So the square root of that number is, so x comes out to being 0.000105,999. Let's call it 106 right there. It's close enough. Now x, if you remember from up top here, that's what we used for the concentration of hydroxide and hydrosulfuric acid. But what we're looking for is this hydroxide ion one. So this is really the concentration of hydroxide ions. So now what I can do, because I'm looking for the pH, let's just take that one and let's figure out the let's figure out the pOH of this solution. So the pOH I can get from taking the negative log of the hydroxide ion concentration. Okay, let's do that. So I've got to go negative log of my answer. Go. So this comes out to, the pOH comes out to 3.975, we'll call it. That's the pOH. So now to find the pH, I'm just going to take 14, subtract that answer. 3.975. 14, subtract that answer. Comes out to 10.025. 10.025. In looking at sig figs, sig figs, where's my question? Uh-oh, I lost my question. It was up there somewhere. 2 sig figs in the question. And so in my answer, I have to give 2 sig figs. Boy, I can't scroll things. Oh well. In my answer, I have to give 2 sig figs. And so in pH, that'll be 2 decimal points. So it'd be 10.03. Why did I write 14? 10.03. That would be the pH of the solution. Hopefully that helps you with that question. It's a tough one because you have to maneuver through knowing what a Ka is of the solution. where'd my bisulfite ion go? Right there. So knowing that that's a Ka, and because I'm using this thing as a base, I need a Kb value. So I found a Kb value. Then I can use that to figure out, so that's my Kb, or my equilibrium constant. And so I can write an equilibrium equation for that top equation that I had, and plug in everything, and I know everything except for those top two. That'll give me the hydroxide ion concentration, which I can use the pOH formula to figure out what the pOH is, and finally subtract from 14 to get the pH, which came out to that. Hopefully that helps a little bit. Tougher question.